This video goes through a couple of parallel lines and proportional parts theorems that you'll use to solve some problems. Let's take a look at the first theorem together. So the first theorem states, if a line is parallel to one side of a triangle, and it intersects the other two sides in two distinct points, then that line separates the sides into proportional segments. So in other words, this line separates this length into proportional parts that follow the same proportion as that length. So let's get a couple of proportion examples. One possible proportion is to say b divided by a equals c divided by d. Now the reciprocal is also a true proportion. So this theorem is very particular in saying that it separates these sides into proportional parts. In other words, it separates the two sides that are cut. So this length and that length are cut into proportional parts. It does not say anything about the other lengths. I'll color them green. So this theorem does not give us any information about E and F. Instead, we have to think about this shape as two overlapping triangles if we're to deal with E and F. Let me give you an example. So we have b divided by b plus a. In other words, b divided by b plus a, this whole side, is equal to e divided by f. Again, e is a side length of this smaller triangle, and f is a side length of the larger triangle. One other possibility, instead of b over b plus a, we could use c and c plus d. Another theorem we have states if three or more lines intersect two transversals, then those lines are cut proportionally. In other words, b over a is equal to c over d. And there are some alternative ways we can write that as well. Here is another example. We can write the reciprocal. A over b is equal to d over c. And there are a couple other ways we can consider this. We could write a plus b, in other words, the entire length of that transversal between the two parallels. A over b over a is equal to c plus d over d. So that's a possibility. And again, we can also write its reciprocal, just like we wrote the reciprocal here. And then here's another way. We can talk about a plus b, this entire length, divided by b is equal to c over d divided by c. So we have one last theorem, and this theorem is actually more of a definition. The mid-segment of a triangle. The mid-segment of a triangle connects the midpoint of one side to the midpoint of another side. In other words, this point is the midpoint of this side, and likewise this point is the midpoint of this side. So that the mid-segment of a triangle, it's three characteristics. It's parallel to the third side, so we see these parallel markings. The length is half the length of the third side. In other words, if this is 16, this must be 8, or half as long. And then the angles that are created are going to be congruent to the third side. So this angle up in here, let's call that, angle 1 is congruent to angle 2 because they're corresponding angles. And likewise, these angles are congruent because they're corresponding based on parallel lines. So that is mid-segment of a triangle. So this video is solving problems using proportional parts number 1. In order to solve this, we need to set up proportions, and the fact that we have these parallel lines within a triangle tells us we can use proportional parts of a triangle. So 3 and 8 follow the same proportion as x plus 2 does to 12. So let's set up our ratios. So now our job is to cross multiply. 3 times 12 is equal to 8 times the quantity x plus 2. 3 times 12 is 36. and then 8 times the quantity x plus 2. Make sure we use the distributive property. And now we'll subtract 96 from both sides of the equation. Wait a minute. 96? That's incorrect. 8 times 2 is 16. So if we subtract 16 from both sides, then we get 8x is equal to 20. Dividing by 8 on both sides gives you that x is equal to 20/8, which both are divisible by 4, and so we get 5/2 is our value of x. Let's take a look at another example. So here we have two variables to solve. Let's deal with variable a first. Since a refers to the entire side length of that triangle, we want to figure out the other side length in order to set up our ratios. So 10 came from 6 plus 4. So now we have our ratios. We have 7 and a follow the same ratio as 4 to 10. When you cross multiply, we have 4 times a is equal to 7 times 10. And 7 times 10, of course, is 70. And then we'll divide both sides by 4. And that reduces to the fraction a is 35/2. So there's a. Now our job is to also find b. So if we think about this figure as two overlapping triangles, this side, the longer side that I actually drew blue, I think color coordination would say it should be red. So 8 corresponds with b in the same way that, let's say, 7 corresponds with 35/2. Or maybe an easier one would be 8 divided by b equals 4 divided by 10. So let's set up that ratio. So once again we have 4 divided by 10 is equal to 8 divided by b. And then we'll cross multiply. We have 4b is equal to 8 times 10, which is 80, and then divide by 4 on both sides. And now we get b is equal to 20. This video is called Solving Problems Using Proportional Parts, Part 2. In this particular figure, we have these parallel line symbols, and so that means that these side lengths are broken up into proportional parts. And so to set up our ratios, we would use x plus 3 and x minus 2, 7, and we seem to be missing a side. Since the entire length is 12 and part of it is 7, I know the remaining piece has to be 5 units long. So now we can set up our ratio. And then let's cross multiply to solve. 5 times the quantity x plus 3 is equal to 7 times the quantity x minus 2. Let's use the distributive property. And now we can subtract 5x from both sides. Add 14 to both sides. And so we get that x is equal to 29/2. This next problem deals with the second theorem on the front page of your note sheet. So we have x and x plus 5 are split up, and 5 and 14 create the final proportions. Let's cross multiply. (14x) is equal to 5 times x plus 5. Distribute. And then solving gives us that x is equal to 25/9. This video is solving problems using proportional parts number 3. So first off, we need to solve for x, and it's kind of strange since we've got a full side length, 3x minus 2. Well, that shouldn't be too big a problem because we've got 3 and 5. So we can compare proportional parts by adding 3 and 5 together. And so then we'll just cross multiply to solve. So we get x equals 6. Now let's take a look at one more problem. So here we have segment ER is the mid-segment of this triangle. Now remember, mid-segment means 3 things for us. One thing it means is that point E is the midpoint of segment NH. And so that means these segments are congruent. And likewise, point R is the midpoint of NY. So these lengths are congruent as well. A couple other things. The mid-segment is parallel to its opposite side. And also it creates a couple of pairs of congruent angles. This angle is congruent to this angle because they're corresponding angles cut by a transversal with parallel lines. And then also this angle is congruent to that angle. Now the problem asks us to solve for x. So x refers to side lengths, in particular side lengths NR and RY. Now because ER is a mid-segment, I know that those side lengths must be equal. And so we have a couple of terms with an x squared. We have a term with a regular old x, and we have a term with a constant number. So it looks like we're going to have to do some solve by factoring. So let's go through a cleanup session. Let's bring that x squared, 2x squared, over to the other side by subtracting 2x squared from both sides. And then again, since we want to solve by factoring, we'll have to do the same with 7x. And so now we're looking for factors of 12, which add to negative 7. Well, factors of 12, it's either 2 and 6 or 3 and 4. So negative 3 and 4 will do the trick. We have x minus 3 times the quantity x minus 4 equals 0. So now either the first term is equal to 0 or the second term is equal to 0. So if x minus 3 is equal to 0, that means x could possibly be positive 3. If x minus 4 equals 0, that means x could equal positive 4. So now we have two potential answers. Let's just go through and make sure that the side lengths make sense geometrically as well as geometrically as well as algebraically. So I'll take this value of x, maybe I'll try x equals 3 first, and I'll substitute it in for the values of 3x squared plus 12 and 2x squared plus 7x. And both of those end up being 39. So I know that x minus 3 is a possible answer. Let's check x equals 4 as well. Both of those make that length 60. Now since both of these sides are positive, it is possible that x is both either 3 or 4. So we have two answers in this case, 3 or 4. Thanks for watching.